This is an Arduino-based project I'm working on, which is going to be an environmental sensor for coffee trees. The goal is to monitor the difference between shaded and unshaded coffee trees, and what the shade does to, let's say, the soil immediately below the tree itself. One of the sensors that I have on this environmental sensor is a TSL2561 lux or light sensor. This sensor will monitor or detect light in a visible light range, but its maximum capacity is 17,000 lux, and sunlight, bright sunlight, can reach 300,000 lux. In order to detect the full spectrum, I could buy a sensor that's $500 and monkey with attaching it to the Arduino and getting the Arduino to read it, or I'm exploring this option, which is this light crystal liquid valve on top here. What the light crystal liquid valve, or LCLV, does is when I apply current through these electrodes into the liquid crystal, it will darken, and that's what you see happening every 2 seconds there. This is a debug routine that I have looping through, so you can see every 2 seconds the liquid crystal goes dark or light, and the light sensor takes a reading. I'm doing this to see how much light the liquid crystal blocks at various levels. As I apply power to the liquid crystal, depending on how much power I apply determines how much light gets through. For example, at full power on a 5-volt system, it will be nearly opaque. This sensor is a 3-volt base, so I'm not going to get complete blockage, but I get pretty close. And you can see with this light, without any power applied to the LCD, I'm hitting about 160 lux, 150, 160. And with power applied to the LCLV, I'm hitting about 23 lux. So you can see I'm getting a really good blockage of light from this. So this may be a way for me to monitor sunlight and get a full reading, even though my sensor doesn't have the capacity to get a full reading. I'll have to do some math on the back end to compensate for that, for the LCLV. But I think I can get good data, and it will do. This piece of liquid crystal costs $7, and the sensor cost, I think, $10. So for $17, if I can get a working solution that may prove my theory, and then later on down the road maybe I can get funding for the full sensor, this might be a good viable solution for the short term.